All right, people. Hey, let's go to page 207, problem one. Guys, you're on the YouTubes right now. You're on the YouTubes right now. We're going to do 4 problems on page 207 having to do with angular velocity. All right, this question is about the displacement of the clock hands here for 1 hour. All righty. So you have a clock on the wall, not the digital kind, the old school kind. Okay, you have the hour hand, you have the minute hand, and you have the red second hand going around, right? So it asks you, A, in 1 hour, how far does the second hand go? So let's do this in terms of rads, rotations, okay? Not distance, not meters, Logan. Not meters. We're not using meters. We're using rads. So how many rads is a rotation? It's 2 pi, right? But in an hour, how many 2 pi's does it do? A second hand? Okay. And wait. So 2 pi is a minute, and how many times does it do that in an hour? No, whoa. That's a second. How many times does it go 60 seconds, which is a 2 pi rotation in an hour? 60 times. So your distance would be 62 pi's. So that's 120 pi's. Again, we're talking about radians. We're not talking about meters. Just talking about radians, Christian. Christian, the minute hand. So how many 2 pi's would the minute hand go in 1 hour? One rotation. That's 2 pi, right? Now, the hour hand, 1/12. But if you have a 2 pi rotation, what is 1/12 of 2 pi if you multiplied that as a fraction? Pi sixths. So you have 12 numbers. The hour hand only moves one of them per hour. That's 1/12 times a rotation, 2 pi. 1/12 of 2 pi is pi sixth. All right, you need me to do that again there, Indigo? B is just 2 pi because the minute hand in an hour goes how many rotations? Just one. So it goes around one rotation, just a 2 pi. Well, how many 2 pi's does this second hand go? It goes 60 times. And then this hour hand doesn't even go a 2 pi. It goes 1/12. Because why is it 1/12? How many numbers are there? 12. Good. Okay. 2, a rotating toy above a baby's crib makes one complete counterclockwise rotation in 12 minutes. So, or excuse me, in 1 minute. A, what's the angular displacement for 3 minutes? So how do you get angular displacement? How many 2 pi's? How many 2 pi's will it go in 3 minutes? Well, if it goes to 2 pi every minute, how far does it go in 3 minutes? How many rotations? So that would be how many? 6 pi. We're still going to draw a picture, Riley. There's the thing, counterclockwise. Here's the baby's crib. There you go. What do you think? If you go 2 pi per minute and you have 3 minutes, cancel, 6 pi. The angular velocity, okay? The angular velocity, that's in your change in theta over change in time. Well, guys, it's really simple. You go 2 pi rads per minute. That's the answer. They gave it to you. And then C, if the toy is turned off, will it have a positive or negative acceleration? Well, if the toy is turned off, will it slow down? Positive acceleration or negative acceleration? Negative, because it slows down, right? All right. Now, go to question 3. Go to question 3. All right. Number 3 asks you about a pickup truck. So draw yourself a monster truck. Draw yourself a giant Hummer. Giant Humvee. Chris Parham, go get your notebook and draw. Okay. This thing has a radius. We're trying to find the radius of the wheel. It's accelerating at 1.85 meters per second squared. Okay. The tires are going around at 5.23 radians per second squared. So the tires are squealing. The tire fish symbol there. Okay. Change in angular velocity over change in time. They're accelerating at 5.23 radians per second squared. Okay. All right. What is the relation between linear acceleration in meters per second and alpha, fish symbol? Okay, we want to cancel the meters. Let's think about this. Ryan, let's think about this. You're good at units. We have meters per second squared. We want to be left with meters. Okay? So we want to get rid of these second squareds, right? So how are we going to get meters? How are we going to get the radius of the wheel? We want to know the radius of the wheel. Yes, Miss Rapp. Acceleration, linear acceleration equals radius times your radians per second squared. So, Greenie, what that means is we have the linear acceleration divided by our angular acceleration will tell us our radius. Well, how does that work out? Well, this is 1.85 meters per second squared divided by 5.23 radians per second squared. Do the second squareds cancel? They do cancel. Does rads mean anything to us? No. Rads don't cancel meters. A rad is not a measure of distance. So all we're left with is just meters. So 0.35 meters is your radius. But the question asks you what's the diameter. So what's the diameter? Yes. So 0.707 meters equals your radius. Okay? Does everybody see what we did there? Sir? Oh, my bad. Diameter. Thank you. Thank you, Greenie. What's that? Okay, let's review. You got a monster truck. It's accelerating that way linearly. Its tires are spinning faster. They're going, they're peeling out, right? It's at the racetrack. Okay. So this is 5.23 rotations of the tire per second squared. Well, how do you figure out the radius of the wheel? Well, you got to divide acceleration by rotations per second squared. The second squareds cancel. You're left with meters. You understand, Logan? The radians, just pretend they don't mean anything. It's just spins. Okay? I had a problem with that when I was in high school. I'm like, but it's a measurement. It's got to mean something. Well, no, it's just talking about spins. Okay? Alrighty. So that is an example. I want you guys now to do number 4. See if you can figure out number 4. So I'm going to stop this, see if you guys can do it. #YouTube.